Problem 20 reads, a non-uniform beam 4.5 meters long and weighing 1.4 kilonewtons makes an angle of 25 degrees below the horizontal. It is held in position by a frictionless pivot at its upper right end and by a cable 3 meters farther down the beam and perpendicular to it. The center of gravity of the beam is 2 meters down the beam from the pivot. Lighting equipment exerts a 5 kilonewton downward force on the lower level end of the beam. Find the tension T in the cable and the horizontal and vertical components of the force exerted on the beam by the pivot. Start by sketching a free body diagram of the beam. There you go. Okay, so let me see. So the net tension will be 1.4 times 2 cosine 25 degrees minus T times 3 plus 5 cosine 25 degrees times 4.5 plus 5 sine 25 degrees times 0, so that just cancels out, plus this component of 0, the y component of 0, which will equal 0. So then I'm just going to solve for t right here. So t equals 1.4 times 2 cosine 25 plus 4.5 times 5 cosine 25 degrees over 3, which will equal 7.64 kilonewtons. And then to find the x component, I'm going to do p of x minus t sine of 25, and p of x equals 7.64, this number that we just found, sine 25, which will equal 3.23, and then this component will equal p of y minus 1.4 plus t cosine 25 degrees minus 5, and so p of y will equal 1.4 plus 5 minus t cosine 25 degrees, which will equal 6.4 minus the t that we found, 7.6 cosine 25, which will equal negative 0.52 kilonewtons. Okay, so the negative sign of this component, p of y, means that the upward direction assumed is wrong. So p of y is downward.